x is a non-negative integer, then find the value of x. And we have two statements. It's a data sufficiency question. Actually, I'm taking this question because it's quite a tricky question, so I'll take a little more time while answering this question. The first thing that we have to do is to answer this question. The first statement is quite simple. We have to factorize it like x squared minus 2x minus 3x plus 6 is equal to 0, which gives us x minus 2 times x minus 3 equal to 0, which eventually gives us x is either 2 or 3. And therefore we say that the first statement is not sufficient. While we simplify the second statement, there are two ways people solve it, and that's where the trickiness of this question starts coming into picture. Some people do it this way: x squared is equal to 3x, x gets cancelled out, x is equal to 3. Well, let me tell you, in context of this question, actually mathematically we should not solve things like this unless we are very sure that when can we do it. So the problem here is that I have categorically mentioned that if x is a non-negative integer, so the first thing that we need to understand is what are the non-negative integers. Non-negative integers are all those integers which are either positive or 0. So 0 is a very important example that I wanted to bring in picture. Non-negative means something that is not negative. So 0 also comes in picture. And whenever we cancel out the variables like we did here, then the possibility of 0 solution to come in picture gets eliminated. And that's where this thing gets wrong. So the question is, when can we cancel out the variables like this and when can we not? Then the simple answer is that when the variable is non-zero, you can always cancel out the variables in any equation because it's an equal to sign. If there is less than or greater than sign, that means if there is an inequation, then there are some more problems that come into picture because the positive variable can be cancelled out like this, but while cancelling out the negative variables, we need to flip the inequality sign. However, I would like to state that the bottom line is we should never cancel out the variables like this. We should instead solve it this way, like I'm going to solve it for you. We take x common, we are left with x minus 3 equal to 0, which means either x has to be 0 or x has to be 3. And that is why we say that this statement also is not sufficient. The first statement was not sufficient because there was no unique value of x that we were getting. Even the second statement is not sufficient because there is no unique value of x we are getting. X is either 0 or 3 and both are non-negative. Right? And if we had cancelled out this way, then we would have reached to a wrong answer like B. That would have been incorrect. And the next step is combining the two statements. When we combine the two statements, we understand that we have only one common solution, that is x equal to 3, and that makes it sufficient to answer the question. So the answer of the question becomes C option. That is where this question gets answered. However, I would like to state one more change here, and that is suppose instead of non-negative, if we had a term here like positive, then what impact would it make on the answer? Then we should understand that had x been positive, then 0 could have been eliminated based on the definition of x, and the second statement alone would have been sufficient, and in that case it could have resulted in the answer option B. So with this example, I also want to emphasize on the importance of the terms used in the question. It's very important that we pay attention to the term, we understand the term before we actually mark our answer. The moment the term changes, the answers also have potential to change. So please be careful about it, and that is why I call it a tricky question. I hope that helps. That's where I'll stop. Thank you so much for watching me. My name is Bhupendra Singh, an expert at GMAT INSIGHT. Please keep liking my videos. Thank you so much.